What's up, YouTube? My name is Johnny Bannon with Trepid Technologies, and today we're going to be going over GNS3 connecting to the internet. So today, guys, is going to be a moderately long video. What we're going to do is set up NAT/PAT on our routers and use a native appliance to GNS3 to get our whole network topology to reach out to the internet. So I've made a how-to for this on Confluence. So click that link below and follow along. And let's get started. So first thing we're going to do is click that link below and pull up the Confluence page. So as you can see here, I'm going to follow along in this how-to. In the beginning, I give a brief explanation of how this works and what it's doing and why you'd want to do this. So having our routers reach out to the internet gives us a lot more versatility, right? In today's day and age, it's all about automation. So if you want, let's say, a actual Docker Ubuntu guest running in here, and it needs to go out to the internet to clone repositories or download packages via pip or install Ansible, you're going to need internet connection. Or if you just want your computer to actually be automating your GNS3 network, you need to somehow make these routers talk out to your computer outside of their emulated environment. We do that using this NAT appliance. Okay, guys? So what I'm going to do is set up my NAT appliance, set up NAT on R1, give it a name server and have it do domain lookup, have a static route out to this NAT, a default one, right? So IP route 000, all zeros. And then I'm going to set up OSPF between R1 and R2. And I'm going to advertise that default route out here to my neighbor via OSPF. And then when we actually set up NAT on R1, we're going to use ACLs to classify our traffic. Then gig 0 will be our outside interface. Gig 01 will be our inside interface. And we're going to be doing PAT here, so port address translation. So I'll show you how to do that as well. And then again, guys, our operating system is Ubuntu. And I'm using viral Cisco routers for this how-to. So let's go ahead and start GNS3. Bring that in over here. Let's open up a blank project. We'll call this test internet. All right, we're doing this from the ground up. So I'm going to put two routers here. Let me get my NAT cloud. I'm going to rename these R1 and R2 so it's easier for us. This video is good for you guys. I'm going to show you how I actually make our GNS3 topology look a little pretty, right? Make sure I got these to show the actual physical interfaces. Put a loop back right here. Loop back 0. Say the IP address is to be 11.0.0.0/24. All right. The network here will be 10.0.0/24. And then the network for this NAT appliance is actually the local virtual network in our Ubuntu. And it's always this subnet, guys. Always. So in any Debian-based Linux distro, the virtual network that you use even for VMware or anything like that is this subnet. We're going to designate this as .1, this one .2. Spread this out a little bit. I'm going to put this box here. We're going to lower it 1. We're going to style it, give it a different fill color. Make it look clean. And we're going to say static route. Text edit, change the font here. Here, this is going to be for our OSPF network. We're going to lower it 1. Change up the colors. and make this look real pretty. A simple network diagram for us, right? This is what we should do for all of our network topologies to build good habits as network engineers. So when you're doing this on a live network, you actually use that Microsoft program, I'm blanking on it, Visio, and other applications like that to build your network diagrams. So now start these nodes. Let's console into them. So first thing we're going to do on both routers is give them an interface, or set up their interfaces, right? So on R1, gig 0 will be DHCP, and then gig 01 will be the connection to R2, and that's the 10 network. Wait for these to boot up a little bit. Now if you want to speed through this quick, you could just come here and just copy and paste all the configuration that I have. But in this video, we're going to do it by the numbers, guys. Change the host name, R1, give it a name server. We'll use Google's DNS. Have to tell it to actually do domain lookup, so IP domain lookup. Then we're going to set up our interfaces. So IP address DHCP. Let's give it a description as well to NAT appliance. Then we're going to no shut. Then we're going to go into gig 01. Set it up for our connection to R2. Give it a description to R2. No shut. Also, let's enable CDP just in case, right? Then we're going to do the same on R2. They have two interfaces as well. The loop back and the connection to R1. Make sure this is the right one. Gig 00. Yep. Description to R1. IP address. 2. 0. We'll no shut. Then we'll make our loop back. 11.0.1.2.5. 0. We don't need to no shut that. Awesome. So now that we set up our interfaces, let's go back to our Confluence page. Let's see what we do next. So now we're going to set up routing on R1. Okay, it's too easy. Let's go back to GNS3. So what we're going to do here is do a default route out to that NAT appliance. We do this because we want all traffic to go that way to actually get NATed. We could do this, and we can also do this as well. Make it go out the physical interface. All right, guys, both are fine, but I'm just gonna get rid of this one and make sure we have this. Now let's set up OSPF. Set up a router ID because I like things clean. Let's advertise our networks. 5 area 0. We're just gonna do the backbone area on OSPF. Area 0 as well. And then this is the key command we need here. What this command is going to do is send to all of its neighbors a default route, right? It's actually going to come up as an external route in OSPF, but a default route pointing to R1. So all these routers in the topology, if added more, would all eventually send traffic towards R1. All right, guys. Now let's see what's next. Now we're setting up NAT. All right, go back to GNS3, bring up R1. First thing we're going to do is designate our outside and inside NAT interfaces. So the one facing the NAT appliance is our outside, and that's the interface that will be doing all the NAT translation. Then we're going to classify the traffic using a standard access list. I'm going to do a named one. Then we're going to classify all the traffic that we want to translate. All right, and now that we've done that, we do IP NAT inside source. We're going to do a list. That's going to be our ACL. As you can see, we have other options. We can use a route map. That's also classifying traffic. We decided just to use an ACL. And then we're going to pick the interface that we want to actually be doing the translation. And then we're going to do the key command overload What the overload command does is actually make it so we're doing port address translation. Now the next thing we're going to do here is actually test to see if we can reach Google sourced from gig 01. So from the 10.0.0.0/24 network. Let's do it. Let's make sure our virtual interface got created. It did. And gig 00 got an IP address. If we want to do this by the numbers, guys, first we would test our gateway, right? Make sure we can hit it. We can. So now we did that ARP right there. That's why I missed one. And then we would see if we can hit our gateway source from gig 01. We can. And now let's ping Google to see if we reach the internet. We're going to source that from the 10 network. So we're going to source it from this interface. And we are good. Now let's go into R2. Let's set up some routing. So router OSPF1, router ID 2.2.2. And this one we're just going to do all routes, right guys? 255, 255. Because I just want that to come up quick. We're going to give this a name server as well. I don't know if we already did this or not. So now that that OSPF neighbor is up, let's check out what we got in our routing table. There's that type 2 external route to R1. Essentially what this is saying is that, hey, if you don't have a specific route for it, send it here. So now, let's ping google.com from R2, and we are good. So one last verification, guys. What we're going to do is ping Google. We're going to do a repeat of 10,000. And we're going to look in R1's NAT table to see all the translations happening. So we can see our inside global address. That's actually our NAT appliance. The inside local address is actually the interface on R2. So that's where the source IP address is, right? Then that source IP address gets changed to this. And then here's our outside addresses. So what if we did this? It would source that from loopback 0. And now let's look at our translation. Now the source IP address in that packet is 11.0.0.1.2. That's the socket, right? Let's do a quick packet capture on this. We're going to get a lot of ICMP messages coming across. That's okay. And as you can see on the wire, so that is on this interface from R1 to the NAT appliance, we see that the source IP is the NAT appliance's IP address. And then that ICMP message, look at that. Crazy, right? There we can totally see NAT happening. Alright guys, so that's it for this NAT/PAT video. I want to thank you for coming, thank you for viewing, and for everyone here at Trepid Technologies, remember to keep learning every single day. Thank you.